dear friends. So today our topic is integration. This is our part 4 of integration. We have already done 3 lectures, and today we will do the 4th lecture of integration. So in integration we have done many formulas, and we have done this that the integration of xn, what would be the integration of xn, and what would be the integration of like cos x would be sin x, and the integration of sin x would be minus cos x. The integration of sec square x equal to tan x. Why? Because the derivative of tan x is sec square x, so the integration of sec square x is tan x. Okay, so we have done these, and we should remember these, like integration to 10 to 1 minus x square is sin inverse x. And what is the difference between sin inverse x and cos inverse x? Here the minus is at RHS. Okay, RHS, but we can put that minus in the LHS too. Okay, that would be like minus dx upon 1 minus x square, and this should be here plus, and it should be here minus. That would be better way to do. Okay, we should remember these. I also remembered these. Okay, same difference in cot inverse. It has done it in RHS, but in reality it should be in LHS. Okay, so now moving further. Yes. So now moving further, we should know integration is not till here, but we, like some of the main formulas say that how can we find out ax. So to find out the derivative of ax, we should, like, I should first prove it, then only you would be able to understand. Okay, so ax upon log a equal to, let it be y. Okay, let ax, we can write fx equals to y. So therefore ax upon log a would be y. Okay, if the fx is ax upon log a, where a is constant, okay, not a variable, then can we okay, it's ax upon log a, this log a is constant. Okay, so we can remove it before the differentiation. So in mainly we have to do differentiation of ax mainly. Now how can we differentiate ax equal to y? Because that constant can be done anywhere, but the differentiation of ax could be ax log ax equal to log y. Okay, okay, like this we have added log both sides, and therefore now, okay, now this, and then we can write x into log a equals to log y, and we had a constant that was 1 upon log a before. Okay, that was the constant, as you remember that before this was our constant. Okay, 1 upon log a. Okay, now this log a and log a cancel. What do we get? X equal to log y. X equal to log y. Okay, so as simple as that. And now x equal to log y. Now we have just solved it. We have not differentiated it anywhere. Now we get that ex equal to y is that equation, and we have to differentiate it. Okay, easily done. And now it is asking for differentiation, and therefore now we will differentiate. And for differentiation, we know that the differentiation of ex would be ex only. So remember that the differentiation of ex is ex, and the differentiation of e2x would be e2x, 2e2x. Now here are some parabolas. You know that what are parabolas? As the word suggests, that parabola, meaning that para meaning throw, and ball meaning bola meaning ball, is thrown. So we would get this shape like this, or any sometimes like this, and these are shapes that we get. Okay, so these are parabola figures, and parabolas form when the equation is in the form of what? Can you guess it? Okay, so I was telling that parabola is in the form of y is x square plus this. Okay, simply you can say, as you are able to also see also, that only I was trying to explain. Okay, now what are the properties of indefinite integral? Indefinite integral, what does it says? That if you have to differentiate integration fx dx, okay, then that would be, we can cut integration differentiation with this dx cancel and integration d cancel, you can like this say. And you can mainly say that differentiation of the integration of fx dx would be fx, the main term fx. Okay, that is that the same minimalistic thing out in different integration. Moving further, we are able to see that it is d by dx fx equal to fx. So can we write integration fx equal to fx like this? And after the integration you would always get a c constant, because like giving an example, if the equation was before integration x square plus 3 before differentiation, okay, but when we differentiate it we get it as 2x. By integration we can calculate that 2x, if it says 2x, then meaning that it would be x square. But we cannot forget that what would be there was 3, 2, 4, 5, 6, 7, 8, 9, 10 or any constant. So do we just say x square plus c? Okay, that's the difference between integration and meaning that it cannot like form that constant. It does not know that what constant would be there. Okay, that could be only find it when you are given with two values of x and y, then we can find out. Okay, so now moving further, as we are able to see also, it is given that so the family of curves meaning x square plus c, then that c is like x square plus 1, x square minus 1, x square minus 3. There was a diagram also to depict that. And the family of curves here, as you are able to see, this is the family of curves, the same angle, everything is same, just the constant is changing. Plus it could be 0 or minus 0. Okay, only you would see the constant is changing, the variable is the same. Okay, now moving further. Now what we have till now done is that what is the integration and the formulas and the basics of integration. Now we should we are now moving further to TDT concept. The TDT concept is not a new concept, as we have done it earlier also, and hereby I am also discussing it TDT. Now what can we say about TDT? Okay, here as comparison between differentiation and integration, we know that look like here, if k1 is constant, we are assuming that, and it is given in the question that here k1 and k2 are constant. We normally assume it also. Okay, then if k1 is constant, we can remove it before only and then differentiate f and x. Same way integration, we would remove k1 before and integration fx. Same way, and that's the main integration and differentiation. Now our next topic is TDT, that I say, that is the main name, and that we normally that we say is integration by substitution. Why substitution? Because we are changing from fx to ft. Okay, and there is dt and there is dx. Okay, so this is what I am able to say. Now what can we write it before, like yes, now if it is integration fx dx, okay, then I am just giving an example. If x equal to t, we can convert it into any number. If we are just taking an example, if x equal to t, then dx would be equal to dt. Okay, now we would convert, then fx, if x equal to t, then fx would be equal to ft. Then integration, we can write it as ft dt. And right now you would say that what we did not did anything, but when you would be able to easily use this in questions. Just question would explain everything. Yes. Now taking some questions. So sin mx, what does sin mx mean? Here firstly we have to differentiate it, integrate it. So in the first I am writing integration sin mx. Okay, now how can we integrate? We know that m is constant, but we are not able to integrate that. We don't know the value of sin mx. So for that, what we can do, we can take mx as t, and there I had taken an example that x equal to t, that would be anything. Okay, so mx equal to t, then m is constant, so if we are differentiating, we get m dx equal to dt. Okay, meaning that dx would be equal to dt upon m. Now can we say that dx would be equal to dt upon m? So we are changing from sin mx would be written as sin t, and dt upon m, dx would be written as dt upon m. So m is constant, so we can remove it before integration. Okay, like this. And so we get so we know the integration of sin t. This integration of sin t is cos minus cos t. Okay, and cos t, and 1 by m is like this only, minus 1 by m cos t. That's done. Nothing more. And we have to change t back to x, meaning that we had taken t equal to mx, so therefore the equation would be 1 by m and minus 1 by m cot m x. Okay, done. This is the answer. Cos. Now moving further, we have this was the first example that I took, and now if here is the derivative of tan inverse x is this, meaning that if we are taking here, it would be that integration 1 by 1 plus x square is tan inverse x. Okay, so we can solve it by substitution. What we can do, that we would take that 1 upon the tan inverse x is t. Okay, tan inverse x is t. Then dx upon 1 by x plus 1 plus x square would be dt. Meaning that now we have the whole equation is converted. Meaning that this whole is dt and nothing is left, integration. The answer would be integration t, and t that we wrote was in tan inverse x. Okay, that's the trick. That it's you can do it by substitution or any. That's it. That does not matter. Now the question comes that tan x equal to log sec x. This is an important equation, and we would get 1 to 2 or more. And here it is tan x dx log sec x. Now what can we do? How can we prove this equation? We have to first think. After thinking, now you can first method is you can go from RHS, but that is not the way to prove this. We have to go from LHS to prove that LHS equal to RHS. Okay, so we can write LHS equal to integration tan x dx. Okay, now we can write it I need some space. Okay, integration tan x. So I'm now rubbing it as I need some space for writing. Okay, then okay, now I was integration tan x that I am writing and saying integration tan x. Now can we write tan x as sin x upon cos x? Yes, we can write sin x upon cos x. Okay, so integration sin. Okay, here I can write. I think integration sin x upon cos x. Is that much clear? We can simply write sin x upon cos x. Okay, now. Okay, sin x upon cos x. Now, what? Okay, yes. What we can now think. In the thinking brains, I am just giving you a hint. It is substitution. Okay, what happened? It's substitution. Now, can you guess that if it is substitution,